This one is DeepPick. So we've done pick before. Pick is in the built-ins, but this one we're going to be picking deeper. So I don't know how else to say it. So we have this object here. It has a bunch of nested properties, and let's just go look at one of them. So here we go. It uses this dot syntax, so we're going to revisit this. Josh and I did this in a prior challenge called TypedGet, and so we're going to be deep picking from object A and also obj.e. So if we go up and look, A is just number, and obj.e is string. So what we get out of this one is an intersection of A, number, and then just that particular value that ended up with E. So maybe it's good if I show maybe I should grab a solution for get, because we'll probably need it. So here's one. We don't need to look at it. Again, if you're interested in this, go see this video. Yeah, where would you, with those tools, and we have, actually, I'll bring you a couple other ones. We have union to function.
Oh boy.
And union to intersection. Again, if anybody's interested, we just did one union to tuple, and we talked quite a lot about union to intersection. Also, union to intersection is a challenge we did all on its own as well. So I don't think it's cheating to start with those in our toolbox. Yeah, what would you do next?
Well, I might have misinterpreted this this challenge, because the first thing that comes to mind is just making it equal to T of, oh God, what did we just paste in? Get equals get of T path. So that's what I'd start with, because if path is a union, it should be the union of all the.
Let's do it. No, I think that's a great place to start. Path in this case, we have a generic constraint to contend with. Okay, so let's take a look at what they return. So let's go to that one, A4. Why not? So A4 is very close. It's the union of those two objects that we have for get, but it needs to be an intersection, not a union.
Got it. All right, so it's close. We'll have to do a little more, but that felt good to get it so close with 5 characters or whatnot.
Yeah.
10. All right, so the issue is all right, so for the A4 one, the expected result is an intersection. Okay, so it's intersection of union, or intersection to union of the whole thing. Union to intersection of get T path.
That's it. Ding, ding, ding.
Distributivity.
Yeah, isn't that great? I mean, it feels too easy for how difficult this challenge is, but that's because we broke the challenge down into these other pieces. Again, if any of this is interesting, I don't want to shortchange anyone. We have some alternatives to look through, so that'll be interesting. But if you want to know more about how these function and how they work, you go take a look. But this is a cool example of how, like, it may seem esoteric and useless to build these other little pieces, but when you can just stick them together, like we just compose them pretty tightly and neatly, we got a pretty powerful thing out of it that somebody can pass in something that's kind of complicated and get out the values that they need. It's nice. And if we passed a merge into this, then it would stick all of these together, which would be even cooler. I think it's quite a nice feature, quite a nice little type.
Yeah. This is one of the cases where the high-level theory of the type system really actually makes a difference, makes an impact. The distributivity of unions becoming a thing that infects the rest of the type. It's cool.
It's a super powerful. That was definitely something when I started all this that I didn't have a clue about, like distributivity of unions. I was like, I don't know. I wouldn't, if somebody said those words to me, I was like, well, I know all those words by themselves.
Yeah.
So this is another one I found. Let's I don't think we're going to dwell on this one too long, but it might be cool to look at. So it uses union to intersection as well. So that's the same thing that we already saw. And it checks if path extends unknown. I wonder if we really need that. We do need that. Okay, interesting. So path extends unknown. We're going to pick fields at the path out. So this is like our get. And they solve it in a slightly different way. So they're using this tokenized path function, or I think of them as functions, but they're using this tokenized path thing here. it's checking, it's kind of like recursively checking through to see if any particular path is mappable to the object at that position. It's very similar, like I said, to get. This is sort of a different way of solving get. Unless you're like super interested in it, I feel like we can leave it at that. Yeah?
Yeah, that makes sense to me.
Okay. And then we're picking out the field by that path. So we're kind of, this is recursive as well. And we're going to infer out the values and just go deeper and deeper until we get nothing left, in which case we'll just return t, which is, the thing that we want, because all of these terminate with some value. Like in the case of B4 that we've been looking at, a is a number, object.e is a string. So we do need to grab those values at some point, and that's where it happens. And then from there, it's pretty straightforward. This uses this wrap and unwrap. Sometimes I worry about helpers like this because they can make it harder. Like, which one's easier to read? If we go to line 140 here, is it easier to read this? 140?
Yeah, I'm with you on this one. Why wrap is WRAP bracket bracket. That's 6 characters to abstract 2 characters. I don't understand why you would do that. Is there a positive there?
No, I don't think.
I think
it's just like a
word.
Yeah, sometimes it's useful when you're sketching things out to make little, like, very small helpers like that. But usually I find, like, if they do the job, it can be easier because you can read this and see, like, oh, we're wrapping it. I don't know. It's not so bad, but it's also, like, I think a little personal preference. Maybe don't fight with your teammates about it, but if nobody disagrees, do the thing that you think is most straightforward, I suppose.
+1.
And then there's just one more alternative we can look through. This is by Logan70 on GitHub. So UnionToIntersection, yet again, we can't solve this one without that. So we've seen that already. Pick one. So this is interesting. So they said if path is empty string, pick one t with path would be never. So in union, it would be ignored because union never is the empty set, like empty union. So that would mean that it would end up being anded with unknown, which is, it's going to be equal in this case. It doesn't, like, anything and unknown in this case is going to be, like, a and unknown is going to be a, or whatever a is. So we're checking the path, and we're seeing if it extends string. Again, that's to cancel out the never case. And then we're intersecting, we're just picking one thing out at a time. I think I like this solution the best because it feels like we're doing it step by step as we go through the union. You know what I mean?
Yeah.
And it's just doing this.
I see what you mean. I'm undecided here. I like how this goes through and does it in place, but I also like how the building up of the pick and the way the pick gets split up into the stringification or destringification and then the collection.
Mm-hmm.
I don't know. I can see an advantage to both types.
There's place in the world for both. Yeah, for sure. I think there's not much more to say. Do you have any other feelings about this challenge in general, or closing thoughts? Would you use this? I guess that's what I want to know. Could you see this being useful in a library?
Oh God, no. Why would pick isn't sorry, not pick. Get is not something I would ever want to use because of the ambiguity between A.B being the priority versus A, let alone a deep pick. Like, I'm sure there were weird, wacky edge cases where you're writing like a database function that gets database keys or something, and randomly this is useful. But like for the most part, I would strongly push back against anyone doing either the type system version of this or the runtime version of this, let alone both.
Okay. I'm right there with you. I actually really hate it, but it is good to flex the muscles and exercise how to figure out how to do this in TypeScript. But yeah, please, out there in the world, if you're considering making an API that does something like this, just don't. Provide an array of, it's unambiguous. So we talked about what's bad, but what's good is if you provide instead an array. Here, let's fix up this one to show what you could do. Instead of obj dot, you can just provide a tuple with all the positions, and then it's really crystal clear how to grab. It's going to giving me errors because whatever. But if you do something like this, it's really clear because then somebody can do object2.i, and it's absolutely obvious that this is the name of a particular single key.
Yeah. Principal at least surprise. I want no surprises in my code, let alone having to choose between what's surprising.
Great. Yeah, same here. All right, let's go on.